Good afternoon. Today we are talking about note 6.4, multiplying and dividing binomial radical expressions. So we saw a little of this at the end of section 6.3. So when you're multiplying binomials, remember we can always use the concept of FOIL, or technically it's the distributive property. Right? So when we're multiplying our first terms, right, 3 times 2 is 6, and then 3 times 3 root 2 is 9 root 2, right? So technically, when you do the F and the O, that's really distributing the first term. Now we're going to distribute the second term, which would be the I and L when you do FOIL. So inside 3 root 2 times 2 is 6 root 2, and then if you do the last, right, 3 root 2 times 3 root 2. This is where most students struggle. So 3 times 3 is 9. Root 2 times root 2 is root 4. And now you just simplify, combine like terms. So we have 6. We have like terms. That would give us 15 root 2 plus 9. The square root of 4 is 2. So 9 times 2. So that's 18. So 18 and 6 are like terms. So 24 plus 15 root 2. And that would be your product. Now if you look at the next example, right, this is a difference of squares. Right? This is A minus B, and this is A plus B. So remember, that's A squared minus B squared. If you recognize that, it makes it a little easier. You can still use FOIL, like we did in the last example, but if you saw this, it would make the math a tad bit quicker. But let's say you didn't, so 4 times 4 is 16. 4 times 3 root 3 would be 12 root 3. Then we distribute minus 12 root 3, and then minus 3 root 3. So 3 times 3 is 9. Root 3 times root 3 is root 9. And now I just, again, combine like terms and simplify. The middle terms reduce away. So you have 16 minus 9 times the square root of 9, which is 3. So 16 minus 27. So again, if you would have recognized it was difference of squares, you would have gotten to that a little quicker than I did. So you end up with minus 11 as your product. Okay, example 2, multiplying. Okay, again, just like the last one we just talked about, that's a difference of squares. The only difference between the two binomials is one's minus, one's plus. So I can take A, which would be 2. So I'm going to take A squared minus B squared. So A is 2. B is 5 root 6. Square it and subtract it. So this part would be 4. 5 root 6 is a little bit more challenging for a lot of us to do. But if you come over here real quick and you do this more often, you'll get better at it. 5 times 5 is 25. Root 6 times root 6 is root 36. So this would be, right, 25 times 6. So 25 times 6, because the order of operations, right, PEMDAS, we have to do our multiplication first. So that's 150. So we get minus 146. Okay, example 3, multiply. So this is the same thing as root 2 plus root 5 times root 2 plus root 5. So now this is not a difference of squares, so I can't use that little pattern we recognized on the last example. So this I'm going to have to FOIL it out. Use the distributive property. So distribute. So root 2 times root 2 is root 4. Plus root 2 times root 5 is root 10. Then do the inside values. So you get plus root 10 and then plus root 25. Because 5 times 5 is 25. So root 4 is 2. Those are like terms. There's 2 of them. And root 25 is 5. 2 and 5 are like terms. So that's 7. And then 2 root 10. So I had to FOIL everything out. Right? That was my first step. Second step was simplify root 4 and root 25. And my third step was combine the 2 and the 5. Okay. So now, again, working with binomials, right? We just went over multiplication, but there's also division. So when you're dividing by a binomial with radicals, we're going to use what we call a conjugate. So the idea is if you have a plus b, the conjugate is a minus b. And if you have a minus b, the conjugate would be a plus b. So basically what we're going to do is we're going to create a difference of squares so that we can use our pattern of difference of squares to simplify. Okay, so if you're looking at 4 here, to get rid of root 5 minus 3, right, we did this in a previous lesson, and you would be like, okay, well, if you just multiplied by root 5, sure, that would get rid of the first radical, but then the 3 would have a radical. So that doesn't work. So we're going to multiply by its conjugate. So that would be root 5 plus 3 over root 5 plus 3. Again, why is it the same top and bottom? Because we're multiplying a value of 1. So we're just changing the appearance of the fraction, not its value. So we're creating a difference of squares because notice every time we had a difference of squares, so look at example 2, look at the second example in 1, both of those times we got rid of the radicals. So by creating that difference of squares, you're going to get rid of the radical in the denominator, which is what we want. So in the numerator, it's 4 times root 5 plus 3. That's pretty simple. And the denominator, that's a difference of squares. So it's going to end up being a squared minus b squared. So this is root 5 squared minus 3 squared. If you wanted to, you could FOIL those out, but I guarantee that's what it's going to simplify to. So the square root and the square reduce. So you just get 5, and this is 3 squared is 9. So you get 4 root 5 plus 3 over 5 minus negative 9, or 5 minus 9, which would be negative 4. Those reduce, so it's negative root 5 plus 3. There you go. So I created a difference of squares so that I could get rid of the radicals. So it's similar to what we did when we rationalized the denominator. But now we have to multiply by a binomial because that's what we have in the denominator. So if you go to the next example here, right, if you wanted to, you could just do root 2. The problem with that is, sure, it would get rid of that radical, but then it would create another one with a 3. So it wouldn't work. So we're going to multiply by its conjugate, which is basically just the opposite in sign of the denominator. And again, you do top and bottom of the fraction by the same value. So in the numerator, we're going to have to multiply that out. There's no way around it. So we're going to have to FOIL that out. Right? We're going to have to multiply these two together. So 2 times 3 is 6. 2 times root 2 is 2 root 2. And then plus 3 root 2. And then root 2 times root 2 is root 4. And the denominator, again, we have that difference of squares. So take a, which would be 3, square it. Take b, which is root 2, and square it. And now it's just simplifying, cleaning everything up. So in the numerator, right, root 4 is 2. You have 2 and 3, so you have 5 root 2. And 6 plus 2 is 8. In the denominator, we have 3 squared, which is 9. Root 2 squared, those reduce, so it's just 2. So there you go. You get 9 minus 2, which is 7. So it's 8 plus 5 root 2 over 7. So I had to FOIL the numerator, multiply it by the conjugate to get difference of squares in the denominator. So literally all you have to do is square the first term, square the second term, and then subtract the 2. That's how you simplify your denominator. Okay, if you look at example 6, similar idea to the one we just did. So I'm going to multiply by its conjugate, which would be 3 plus root 6. So in the numerator, it's 4x times 3 plus root 6. In the denominator, again, we created that perfect square, the difference. So a is 3, so square it. B is root 6, so square that. So this is 9 minus the root 6 and the square, those reduce, so you get 9 minus 6. So you get 3. 4x times 3 plus root 6. And that would be your simplified fraction. Okay, so you're looking at the next one. And you're like, oh, I get rid of the 2. No, you don't have to get rid of the 2. The 2 is fine. You just can't have radicals in the denominator. Those are the problems. And you can't have zeros in the denominators. But to simplify this, we can split this up. Right? 8 over 2 plus 4 root 2 over 2. So 2 goes into 8 4 times. 2 goes into 4 2 times. So it's 4 plus 2 root 2. So that is the way we could split it up. Okay, last example. Find the unknown side and verify the area. So if I said, for example, this is not the case, but this is like 2 and this is x, right? You would have 2x equals 8. And you divide by 2. That's how you would solve that, correct? Well, same concept. So we have root 6 plus 2 times, we'll call it x, equals 8. So x would be 8 divided by root 6 plus 2. Okay, well that's fine. That's technically an answer, but it's not the simplified answer. So we're going to simplify it by multiplying by its conjugate. So root 6 minus 2. This is going to be how we simplify. So you have 8 times root 6 minus 2. Again, created that perfect squares. So you take root 6, square it. You take 2, square it, and you subtract the 2. So you have 8 times root 6 minus 2 in the numerator. The root 6 and the square reduce, so it's 6 minus 4. Right, because 2 squared is 4, so you end up getting 2. And 2 and 8 can be simplified, so 4 times root 6 minus 2. So there you go. That would be your answer. So again, when you are working with division, right, we often use multiplication. So I don't want radicals in my denominators ever. So in this case, since it's a binomial, we'll multiply by another binomial, which is we'll call in the conjugate. By doing that, it creates a difference of squares to make it so the radicals disappear. They reduce away. So that's what we're doing. Right? When we worked with rationalizing before, right, when we have like 1 over the square root of 2, we did the same thing, but we multiplied by root 2 over root 2. We created a perfect square, so the radical and the square would reduce. Now, since it's a binomial, we're creating a difference of squares to get the radicals to simplify. So please make sure you answer the essential question with a 3 to 5 sentence summary at the very end here of your notes. Once you've done that, you're done with your notes. Have a great day.